Hello. Very happy new year to everyone. Uh, Today this video is about a few many things which involve computer networking, uh, programming, and to some extent, maybe in some of the cities that will follow after this video, cryptography as well, how to secure communication. Well, we have now a trend to develop one's own protocol. At least what I see in my LinkedIn posts, in my LinkedIn feeds, I see people asking how to build one's own application layer protocol, what protocols are, how many protocols do we have in our networking stacks, and how to secure a communication from one end to another. So to keep things short, we'll discuss about what protocol is first, then we'll go ahead and suggest a way to learn, create your own protocol. And that apart, of course, I'll have coding experience, coding here as well in the but for the interest of time, I'm not going to, show everything up and running. And I may or may not use an ID. I'll just write the code snippets, maybe on something as simple as a notepad, and let's see. So, what a protocol is, I knew that most of us already had a thorough understanding of computer networks in one's uh, bachelor and, if required, and if applicable, master's level as well, or maybe in the schools uh, or upper high schools. Yeah. So protocols are nothing but a set of rules which we need to abide by in order to understand each other. Let's say you and I are communicating together, but how do we understand each other? That is what protocol is. Let's say I speak my native mother tongue, which is, I'm proud to say, Bengali, and someone else in the audience is speaking, let's say, English. Now, the communication will be one-sided unless we understand each other. So there are two options, like uh, uh, either both of us agree on speaking a common language which both of us understand, or one, what I speak should be understood by the recipient, and what he or she speaks must be understood by me. Of course, the latter doesn't seem to be very promising because we might have, let's say, 10 people. So it will end up in a, you know, long in a long chain of, permutations, right? So there'll be as many as NP2, uh, you know, NP2 languages, and that is nothing but infeasible. So what we can do is we need to agree on something which is common between he and me, means someone who I am communicating to, or and someone who is communicating to me. It's of course a bidirectional communication. Now let us also bring in a few more participants here. It is not necessary that we all speak at the same time, but let us all agree on something which is common among us. Let's say we chose the internationally accepted language of communication, English, to continue. Well, so protocol is nothing but a set of rules which all the participants in a network must adhere to in order to make the communication a successful one. Nothing more than that. Now, when it comes to networking stack, what it is? Well, briefly, it is a software, something which someone or a group of people with much advanced level of understanding of computer systems and network might have written using maybe, let's just see, as simple as C. So what we have is from the very up, bottom up, there is an application layer, we have a transport layer, we have a network layer, and the layer below we nowadays commonly term as link layer, or which we in during our school days we used to term them as as separate entities like a data link layer and a physical layer. So for nowadays we are more used to calling them uh, link layer. Okay. Now what happens if I really wanted to apply something which is my own in the very application layer? Well, application layer is nothing but your own layer of protocol, your own application. Now, how does it send data? In the form of messages. And since we're running at the very topmost layer, we must have knowledge of the recipient's host address, which is the IP address, maybe V4, maybe V6, whatever, but it is a layer 3 address, so it's an IP address. And we must know which process on the recipient's computer consume those message, which is identified by a port number, and the considered port is tied up at the process layer and process level and the transport layer. Now, you might be wondering, like, if I know the IP address, why do I need a process identifier? Here's why. Let's say on my system, I have been running a bunch full of application. One is this Zoom meeting. On another one, maybe YouTube, a mail client, a video player, and maybe the Windows updates on its own is downloading a few updates. Now, how does my computer understand some data packets which arrive at its network layer, whether it is destined to be consumed by Zoom or YouTube, or maybe it's a Windows update? How does it do that? That is what where the concept port largely comes into picture. Well, I want to design my own protocol. So without much ado, let me straight away show you how I do that. It is something which has to be on the top of the transport layer. Well, let me today give a prelude to how I design it or how it may be designed. Just a second, my mouse seems to have frozen. Let's see. Let me, no. Once you're able to see my screen, I think you're seeing it. Yes, it must be. Well, I have to write my own application. I must write my own application layer protocol. Protocol. So what I have to do? Nothing but some application design a protocol, design a rule, and that's it. Then consider different things, how it is consumed and produced. Uh, Performance in a communication system is very important. So performance consider a lot of things like compression, uh, unless of course you are making something very public, you would at least need some security make inside your protocol. So right, so security, and there are a number of things that will come into picture. Will not go into details right away. Well, so I am going to design a system. This is the transmitter and this is the receiver. What the transmitter will do, let's say transmitter initiates the connection and receiver receives it. Now what happens? Let's say you and me are communicating. I simply tell you like, hey, what's the time now? And what is the weather now? Right? How cold it feels at your place now that it's the winters. So two things like, let me ask you a question and let the receiver answer it. Or maybe the other way. I give you some command to execute, you execute at your computer. It can be anything. So, well, let's go ahead and do some meaningful thing after this. But initially, let us do one thing. Hey, how is the temperature? How is the weather? Receiver will respond with something like, it's it's 10 degree Celsius. Well, so these are all text, right? Now it seems like quite something like as dull as a chat message, right? Well, then what? Well, chat, of course, it is based on the protocol, right? So what I need to do is like, let's say, we'll analyze the HTTP protocol some other time. So let's do something like I make some protocol. It may be text based, it may be QR code based or anything. So first thing first, like I'll give you some no pre-known comments like temperature, humidity, time, right? And what else? Like, oh, maybe uh, prob or let's say what? Uh, sun. Sun is up. Receiver, on the other hand, will respond with those things. So, what I can do in order to build my application layer protocol, it's an application layer protocol. Again, I repeat. So it has to be over some transport layer protocol, of course. let us choose something which suits our requirement. So initially, let me choose this, the same good old transport layer communication, that is on TCP. TCP, of course, TCP goes over IP now. So what I must do is I must open a server socket, right? I'm writing my code in Java. Let's a new server socket. Server socket. Let me define a port number. Port number. This port number you might define. Let's say port. It might be something uh in the in some in a 2 byte sign integer. Of course, we are not going to use the reserved ones, which are reserved by Yana. So let me choose a port like something 8. Well, fair enough. Now I'm using something like which is compatible to Java AC8. In higher versions of Java, you might have a wrapper around server socket, right? So this socket uh, API um, itself might have undergone some drastic, performance improvements and changes. However, so I'm for the sake of cutting it short, I'm sticking to Java 8 only. Now, what will happen is, like, let's say for while server socket dot, hold on, let me do it like this. While true, it's an infinite loop. Socket connection, server socket dot accept, right? So what happens is, like, whenever someone mm, connects to the socket, it will get connected. Now, what I'll do, I'll open an input stream. I'll open an output stream. Since it's mine is a text-based protocol, I'll be simply happy with parsing the text. And so let's say string input command, something like, I'll not, of course, I'm not going to write the full code over here. Now, something like I'll use a buffered reader, read line. I could have done it otherwise as well. Now, switch input command, case, let's say temperature, current temperature. Hey, note it that this is not not an inbuilt function. So current temperature, how can I get it? I can get it from, let's say, from a sensor, from a thermometer, or which is, of course, known to the computer application. Nothing other than that. Case, similarly, case, um, date. Well, this is something which makes more sense. That time, local date time, but now, right? Well, it will not return, right? So what it must do is, like, convert it to a string, convert it to a string, str, temperature. Now I have an output stream dot write UTF, something similar. I'm not really sure whether it's right or not similar. And of course, I must flash it out. Stream dot flash, right? Something similar. Depending on depending on this, I similarly I'll do the same. Stream dot write. And so on. This is how basically an application layer protocol may be built. However, there's certain consideration like this example is itself not a very, it's easy to understand, but not very, realistic in nature. So let me tell you something which makes sense, more sense. So what happens is, let's say well, when it comes to talking about protocols, we generally do not talk the text way. However, still, I must remind you of HTTP, which is a purely text-based protocol. So unless you need a text-based protocol, uh, right, you should stick to some, kind of a protocol unit or maybe a protocol structure. For example, if I break my things like this, let's say the first two bytes, first 2 bytes of a packet needs to be, let's say, a string command, a string command. So of course, since the first 2 byte, a comment, not a string, let's say a comment. Well, in a 2 byte space, I have the flexibility of passing as many as 2 to the power 16 types of comments. However, I'll perhaps break it like 1 byte and 1 byte, right? So maybe in that case, let's say 14, maybe like something like 16 plus 4 equal to 20, 20 in decimal, right? So which might imply something which the recipient end understands. So maybe 20 in decimal means to open up a notepad. Well, first 2 bytes, it is a command. Then for bytes 3 to 4, or let me say something like this. Uh, 8 bytes. Byte number, I'll say 2 to third, third to 8. 8 bytes. It is basically a long which takes milliseconds. Milliseconds. So when to let's say my protocol is something where I uh, want the sender to send out a comment, and in its first 2 bytes, so I have as many as 2 to the 16 uh, comments to provision here, which is of course more than sufficient for now. Now byte number 3, or basically the third byte onward, next 8 bytes will be a long which will contain uh, uh, um, an integer, or basically an unsigned long in Unix epoch, which tells the receiver when to execute that command. Well, that sounds interesting, right? So the receiver, it will do, it will communicate with it, will send this payload. The payload will look something like this. Let's say I have this 8 bytes. So as I said, that 20 is open notepad. So it will look like 1 and 4. 1/4 hex, the first 2 bytes, right? 1/4, the first 2 bytes, right? And next 8 bytes will have the what I'll say, an epoch, eclipse epoch. So you can convert it as well. Something like maybe system dot current time in in millis or something, plus give some long value, long delay. Well, so that value we can provision here. However, that is not going to be provisioned in this way. So you need some class like byte buffer or something, or if you're using in a different language, you can take help of that particular l- language, its libraries. Now, what happens here is you send out this. So what the recipient here, recipient can be, I'll say it can be either the server socket, it can be the socket initiator as well. So in this case, let's say I have a socket, an initiator, socket is equal to new socket. I'll just provide the IP address, server IP address, right? And then the port number, same as what we gave in case of the server socket, right? So what we'll do is it will connect in a happy case. Now we'll obtain input stream. You might prefer wrapping it up inside a character stream or whatever. After a string, you can obtain an output stream if you required. Here I don't. Yeah, I do. Output stream. Well, in communication, it's very important to understand what streams are. It is not a Java stream which is used in conjunction with collections. This stream is an IO stream, right? So these IO streams are basically nothing but when I speak out, you are listening to me, and my mouth is producing something which is a stream of sound. So what is my output is input to your ear, and what you speak is input to my ear. So in the communication system, if there are, let's say, two participants, uh, one's output stream is input to another, and one's output stream is input to the other one. So this way the communication happens. Now, now we are in application lead, so you can simply go ahead and make this happen. So finally, what happens is the server, uh, or let me say in this way, like one of the participants, right? One of the participants might, request a comment to be executed, let's say at 6:30 a.m. On a specific date. The recipient will receive the comment, will act accordingly. Now, a few things that we need to remember is like, as I said, that we need to be much more, considerate about the performance and considering certain things. Protocol is not only just, protocol units or the texts or the payloads, how it parts, all these things. It also, requires a thorough system designing. For example, here what happens is I might have a server client model. So a client model is a system like someone opens a socket connection and I send it out. Now, question is, where do you want the code to be executed? On which computer? Is it on the one that opened the server socket, or is it some other computer which might have connected to, uh, which might have connected to A. So it it depends on what the requirement is. For example, if the requirement is like you can ask any computer on the network to do something or act accordingly. Obviously, in between there has to be a kind of a server itself. Why? Because it's not possible for us to know IP of each and every participant, right? And even though we know, right, there is no guarantee that the ports we are trying to right, reach out to is indeed the port where the application is running on, let's say, uh, computer A, though it might be the on computer B. So the considerations is like we should not assume assume that the ports are open and accessible and so on. So we what the model will be like, there is a server. Now we have client one, then we have client two, and so on. So what happens is client one speaks to client A, server. Client two does the same. So client one mentions, asks server to relay the message to C2 to execute a code at a particular uh, instant of time. Now, of course, when this model comes into picture, the identity is one thing that needs to be taken care of, because this server must be known by some other, server must be known by something, right? Must be known by an agent ID or maybe a user ID, right? So to keep things simple, we eliminate this C2 over here. We have only one client. So they connect over uh, a transport layer protocol. Let's say that let that be TCP for the sake of reliability, not simplicity, reliability. Because we want our communication to be stable and reliable and be, you know, connection oriented. However, in certain cases, we do not need a connection, so will not bear to have, an overhead of establishing a TCP connection initially, but we'll go for, or we can even go for, we can accept to lose some part of communication. That's not so important, but what important is speed. However, so those things are different. We are not going to dive it right away. So client and server, they communicate through TCP. They have agreed over some common protocol, and then we need to understand why and how they need to understand each other. So that's an application layer protocol. Now it can be text-based protocol. Well, the browsers are all aware of the text communications, and they know what things are. So I'll be discussing more about it in a different video. For the time being, I'll just give a hint what you can try out and go ahead and implement on your own, because this is very, very easy, very, very easy. Well, what has to happen is like my communication protocol is going to be an image oriented protocol. So whatever communication we need to make is going to be an image instead of a text or any binary, any protocol buffer. So what has to happen is my communication will happen in form of images. Maybe let's say, to be very precise, let me make this like server and the client they communicate with each other using QR codes. So what happens is C1 sends the client sends some QR code with some of course some, again it comes when it comes to QR code, of course where it is nothing but some text that we are wrapping in the QR. However, so we are transmitting some QR code, some raw bytes containing a QR code. We're updating those raw bytes and forming the QR code, and from the QR code, we're extracting the text, and then we're acting accordingly. So that is our requirement, right? It might so be like as simple as like the client can connect to the server. Now, after connecting, this client sends a QR code. What server does is server just forms the QR code out of the raw bytes and then extracts the text from the QR code and it saves it maybe on a local storage, maybe on a local file or maybe database or wherever. So let us not complicate, just print it for now. So that will also be a communication level, application level protocol. However, it must be noted that when you come and communicate, we want to make the communication very crisp, not something like how I'm speaking. So it has a lot of redundancy in between, right? So it will be best to have everything crisp in such a way that it doesn't have significant loss of information, nor does it have too much overhead at the receiver end to uncompress it. Well, the more about it I'll be discussing in a subsequent video.